Assalamu alaikum everyone. In this video we are going to learn how to represent a quadratic relations and what are different ways to represent a quadratic relation. So basically there are three different ways to represent a quadratic relation. The first one is by using a table of values, the second is by using graphs, and the third is by using an equations. Let's begin with the first way. The first way to represent a quadratic relation is by using a table of values. A table of values represents a quadratic relation if its second difference is constant. Means we need to find out the difference between the y values, the first difference and then the second difference. If the second difference is constant, then we can say that the given table of values represents a quadratic relation. Okay, let's do an example of table of values and let's see. Let me take a table x and y. Okay, let me write down the x values are 1, 2, 3, 4, 5, 6, and the corresponding y values are -5, -8, -9, again -8, and then -5, and then 0. Okay, let's find out the first difference. So we need to find the difference between the number -5 and -8. Again, second number subtract the first number, so it would be -8 subtract -5, so that would be -8 plus 5, so that is equals to -3. Okay, now the difference between the number -8 and -9, it would be -9 subtract -8, so it would be -9 plus 8, so that is equals to -1. Right, now the difference between the number -9 and -8, so it would be -8 subtract -9, so that is equals to -8 plus 9, so that is equals to 1. The difference between the number -8 and -5, it would be -5 subtract -8, so that is equals to -5 plus 8, so that is equals to 3. Now the difference between the number -5 and 0, it would be 0 subtract -5, that is equals to 0 plus 5, and that would be equals to 5. Right, so we have done with the first differences, and you can see that the first differences are not constant, all the first differences are different. So let's find out the second differences. So the difference between the number -3 and -1, -1 subtract -3, so that is equals to -1 plus 3, so that would be equals to 2. The difference between the number -1 and 1, so 1 subtract -1, so that would be 1 plus 1, so that would be equals to 2. The difference between the number 1 and 3, so we have 3 subtract 1, that is equals to 2. The difference between the number 3 and 5, so we have 5 subtract 3, that is equals to 2. So we can see that the second difference is constant, that is 2. So when the second difference is constant, then we can say that the given table of values represents a quadratic relation, right? Let's move to the second way to represent a quadratic relation. Okay. The second way to represent a quadratic relation is by using a graph. A graph is representing a quadratic relation if it represents a parabola. When a graph is a parabola, then it means that the given graph is representing a quadratic relation. Let me draw some examples of graphs. Okay, so if I have a graph like this, so it is a parabola and its opening is upward, if I have a graph like this, it is again a parabola and its opening is downward. So both the graphs are representing a parabola. So both the graphs are representing quadratic relations. Let me take a counter example. If I draw another graph, if I have a graph like this, so this graph is not representing a parabola, right? So the first and the second graphs are the parabolas and the third one is not a parabola. The first graph is and the second graph represents a quadratic relation, and third one is not representing a quadratic relation because it is not representing a parabola. Let's move to the third way to represent a quadratic relation. Okay, the third way to represent a quadratic relation is by using an equations. Okay, equations are representing a quadratic relation if they are the polynomials of degree 2. Any equation that is representing a polynomial of degree 2 is basically a quadratic equation, or we can say a quadratic relation. Let me take an example. If I have 2x squared plus 3x plus 4 equals to 0. So that is a polynomial of degree 2 because the highest exponent is 2. The highest exponent is 2, so the given equation is representing a quadratic relation, right? Let me take another example. If I have 4m squared plus 3m equals to 1. This equation is again a polynomial of degree 2. Its highest coefficient is 2, so the degree of this polynomial is 2, so this is representing a quadratic relation, right? Okay, so these are the three ways to represent a quadratic relation: by using a table of values, by using graphs, and by using equations. I hope you understand all the three ways clearly. If you want to watch more and get updated, then please subscribe to my channel and hit the bell icon for the latest updates. Thank you.